we'll be looking at modeling real-life situations with parametric equations. So, in the very first example, we were told that airplane's position time t seconds after takeoff is modeled by the following parametric equations. X is v multiplied by cos t, and because we are calculating a position, if I remind you about applied maths, is the displacement. Therefore, your v has to be multiplied, value of v is multiplied by t to give us the displacement, that is x value, and displacement in y direction is again v in y direction multiplied by time to give us displacement in y direction. So v is the speed of the plane and theta is the angle of elevation of its path, and x is the horizontal distance traveled, y is the vertical distance traveled in meters relative to fixed point origin. So when the airplane has traveled 600 meters, it has reached a height of 120 meters. And we are assuming that theta is fixed here. I know in real life airplanes take off in a rather exponential way, but what we are assuming here is that the airplane travels in a linear direction. Okay, so we're going to exclude the fact that yes, the airplane does need to speed up in its initial stage of takeoff. So we are making certain assumptions here to help us solve this problem. So I understand it may not seem realistic, but that's the fact that it is. That's the assumptions we need to make this problem easier for ourselves. Okay, so from the fact that x and y coordinates are given to us here, 600 and 120, then we can calculate the angle of elevation. So let's do that first. That's simply opposite over adjacent of the triangle, where we're gonna take the tan inverse of 120 over 600, and we find our angle of elevation to be 11.3 degrees. Then in the next part of the question, we are asked to calculate the parametric equations given that the speed of the plane is 50 meters per second. So all we have to do now is substitute the fact that we found the angle of elevation to be 11.3 and substitute value of 50 for v into these two equations that we were told. So we are going to simply do some simple calculation, put these numbers in your calculator, and you end up with 49 to be exact, and the value for y will come out to be another exact value to 3 significant figure. You're going to take 9.81. Wow, that's a familiar number. Okay, so then we have now calculated what x and y are uh, in terms of t. Okay, so we found these two to be parametric equations of, well, simplified version of parametric equations. Now in part C, we are calculating the vertical height of the plane after 10 seconds. So height is referring to y. We have to just take the y equation here and substitute 10 for t, because, well, t is measured in the speed, if you remember from the previous part, was given to us in meter per second, so the units are already worked out for us. So multiplying that by 10, we get height of 98 meters. Then in the next part of the example, we asked to show that the plane's motion is a straight line. So uh, we take the x value here and we can rearrange it for t. We'll have x divided by 49, and y is simply 9.8 times t. So this t is going to go here, and that means that 9.8 will be multiplied by x over 49. Now 9.8 is divisible by 49, and once we do that we get 1/5. So x over 5 here is the answer to our question. So why is this in linear fashion, or why is the plane's path linear? Because we have factor of 1/5. This is a constant multiplied by x, and x is power of 1. So this is not a polynomial, this is just a linear equation, and this is a constant here. Okay, so that solves this example here. So we found the gradient to be 1/5. There is another part to this problem that's asking us explain why the domain of t is positive and not is not realistic. So it's asking us to criticize the model and come up with some answers. Well, the the plane continues to climb up to a certain point. The the gradient of the flight, or the flight path of the plane, cannot remain at this constant increase of 11.3 degrees. So the angle of elevation has to change, and therefore the value of t multiplied by any any value any other value is more realistic. The plane cannot rise indefinitely. Okay, so let's look at the next example. In this next question, we are modeling a stone's trajectory thrown off a cliff projected at a speed of 5 meters per second, where the cliff's height is 25 meters above the sea level or the ground, and the angle of projection is 45 degrees. So we were asked to, uh, well, the position of the plane of the trajectory is given to us with these equations. Y value is negative quadratic, and x value is a constant multiplier of t. So x is a horizontal distance traveled, so the x is representing the displacement in x direction, and y is representing the displacement in y direction. So given that the model is valid from the time the stone is thrown, that means t is more than 0, and it hits the ground, find the value for k. Well, we need to figure out at what time will the stone hit the ground. So we have to use the Subat equations that we learned from our applied maths book. So this we can calculate to and figure out what's the value when the y equals to 0. So we can solve this quadratic equation either with the quadratic formula or use a calculator to figure out the time at which the stone hits the ground. Now, negative values for time is not acceptable here, so we're going to take the positive value here to be exactly 2.648, and then that means that of course the stone is not going to travel through the ground, so the model will stop at the point where the stone has reached the ground level. So we're going to take k to be 2.648. So that makes the model realistic, and we are asked to find what's the horizontal distance that the stone has traveled when it hits the ground. So the x direction, we are actually, well, the graph is not very realistic. Let's assume that the stone is projected from this point at 45-degree angle, so that our graph will make more sense. Okay, so what we're going to do is just substitute the highest value of t into the equation for x, and that would simply give us an answer that is realistic. And because this equation is an increasing equation, the highest value for t is the highest value for x. So the maximum distance in x direction is 9.36 meters. All right, in this next example, we are told that the motion of a figure skater relative to fixed position origin time t minutes after it starts moving is modeled by parametric equations that are given to us. And x and y are measured in meters. So plotting that graphic calculator will give you such a graph, and we are asked to calculate the coordinates of the figure skater at the beginning of their motion. So that simply means substituting t equal to 0 into both of these equations to figure out the x and y coordinates. So putting t equal to 0, we'll get 8 multiplied by 1 because cos of 0 is 1. So value for x is 8, and value for sine will be sine of negative pi over 3 multiplied by 12. So putting that on your calculator should give you negative 6 root 3. So that's the coordinate where the figure skater starts traveling. So it's somewhere in the third quadrant here. I'm not sure exactly where, but that would do. Actually, sorry, it would be in the fourth quadrant here because x is positive and y is negative. So in the next part of the question, we are asked to find the coordinates of the point where the figure skater intersects their own path, given that it takes place on the x-axis. So they are talking about this point here. Okay, what's the value of can we assume about this coordinate here? The value of x we don't know, but the value of y we can be sure is 0. So we're going to take this equation here and set y equal to 0 and solve it for t and substitute that into the formula for x. So when y is 0, we will have this type of setup. Dividing by 12 will give us sine of 10t minus pi over 3 is 0. And we take an inverse sine of 0, we will have either 0 or pi over pi. But we are just going to take the first principal value and solve for t. So the first time that it will cross the that its own path, the time will be pi over 30. Okay, so I know there is another, once you solve this equation, there is another answer that is pi, but we are just taking pi over 30 for the first point in time and substituting into x value, we will have a negative number, which is correctly minus 4. It does have a correct sign. So then we have found the coordinates of this point here. Okay, so that solves this part of the problem. Then we are asked in the part C to find the coordinates of the point where the curve intersects the y-axis. So we see here there are 4 coordinates where the curve crosses the y-axis. So we're going to substitute x equals to 0, solving this equation for x being 0. That means that cos of 20t is equal to 0. So take cos inverse of 0, we will have a 1 here. And 20t, sorry, my bad, we will have pi over 20, pi over 2. Okay, looking at the next part of the question, we have been asked to calculate the coordinates where the graph cuts the y-axis. So that's those 4 coordinates there. we can see on the graph we have these points that we need to figure the y coordinate out. We know that x value is 0 on the y-axis, so we take that for granted, and we are going to set this equation, the x value equal to 0, and solve it. So dividing 0 by 8 will leave it as 0, and then cos 20t will be 0. Now taking cos inverse 20t, we are ignoring the negative answers. We are going to take the positive answers, and we'll have pi over 2. Now we already know that we need to find 4 answers. Cos curve repeats itself every 2 pi, so pi over 2 is here. It just happens that the other answer, cos of theta, is equals to cos of 2 theta minus this 2 pi minus theta. So 2 pi minus pi over 2, it will give us 3/2 of pi. So so the first two principal values are pi over 2, 3/2 of pi, and adding 2 pi to each of them. So I'm gonna rub off my handwriting here, and so we will get 4 answers. Adding 2 pi to each of these will give us 5 over 2 pi, and adding 2 pi to 3/2 will give us 7 over 2 pi. Now dividing all these values by 20 will leave us with a denominator of 40. So these are the t coordinates where we can find the y value. We need to substitute each of these t values into the y equation here to figure out the exact value for y. So let's do that here. We are simply substituting those 4 values into the equation, and we should have 2 negative values and 2 positive values, and they turn out to be pretty symmetric with each other, which confirms the shape of the graph is symmetric as well. Okay, so I hope you found that helpful for seeing the y coordinates there. Now the next part of the question is asking us to find how long will it take for the figure skater to complete one figure of 8 motion. Alright, so we knew that it started somewhere in the fourth quadrant. It has to complete its full journey to get back to the original position. Now, what is the original position is when it was 0, okay? Both sine curve and cosine curve need to have completed one full period. Okay, so I put the sine curve, this is a cos of here, and for t to be between just 0 and pi here, you'll see that the cos curve will repeat itself. Okay, so we need to actually find at what points will both of these x and y values have completed the full period. As you can tell, the periods for cos 20 are higher than the periods for sine, okay? Because sine has a coefficient of 10 in front of t. We will only have 10 periods in the sine curve and 20 periods in the cosine curve. So we need to basically find the lowest common multiple of both of these curves, okay? Okay, as I was saying, the graph for cos will complete its 2 pi, its whole period in 2 pi over 20. Okay, because the coefficient of 20 there, 2 pi will be divided by 20, and there would be one whole period, of course, completed in pi over 20. Now, which one is larger, pi over 20 or 2 pi over 20 or 2 pi over 10? 2 pi over 10 is the period for the sine curve, okay? So the sine curve will complete its turn at 2 pi over 10. So putting these values here, putting the 2 pi over 20 here, and that's for x, and the 2 pi over 10 is for y. Now the lowest common multiple of the two turns out to be 2 pi over 10. Okay, so 2 pi over 10 or pi over 5 is actually the point in time where in where the figure skater would have completed its one full turn on the figure of 8. Okay, so I hope you found that helpful. It helps to go over these examples again, and I'll see you in the next section of the course.